we'll start off on our first lesson having a look at probability together. So this is our next topic after the number work that we've been doing. And we're really going to start off by just looking at words to do with how likely things are. So things that can happen, we call those in probability events. It just doesn't have to be an event. It's not like a football match happening with a particular outcome. It just means something happening. So it could be that a coin lands heads, a dice lands on a 6, something like that is an event. Okay, so let's just make a start. So what we have on this slide here are 5 bags. These bags have got blue and white sweets in them. And we're asked to match the statements that we've got to the bags. Which bag is it talking about? So our first statement says, it's certain that Ethan will take a white sweet from this bag. So which bag would it be absolutely certain that he'd take a white sweet from? The second statement says it's likely that he'll take a white sweet from this bag. So we have to think, which one is it likely he would take one from? And then the third statement says it's an even chance that he'd take a white sweet from the bag. So if it's certain, that means there's got to be no chance at all of us getting a blue sweet. So hopefully we can see that that's going to have to be bag E. Okay, bag E is the one that has got everything in there is white. So it's going to have to be bag E. Absolutely certain we'll get a white one from there. There's no way we could get a blue one from bag E. If we now go on and have a look at the next one, so it's likely that he's going to get a white sweet from the bag. So there's got to be a good number of white sweets in this bag. Probably not very many blue sweets. It's going to be likely that he does it. And I think looking at that, the best option we've got is bag A. Look at bag A at the top. There are lots of white sweets in there and only one blue sweet. So I think bag A would do for likely. It's an even chance that Ethan will take a white sweet from the third bag that we want. So it's an even chance, which means it's as likely as it's unlikely that it'll happen. We've got an even chance. So we need an even split, an equal split, same number of whites, same number of blues, and that would give us an even chance. Looking at that, bag D seems to do that pretty well. They've got 3 blues and 3 whites in there. So I'm going to say bag D for that. So one where it's certain. Okay, we've got to have just white ones in there, nothing else. So that's bag E, just the white ones. If it's likely, well, for likely, we've got to have a good number more white ones than blue ones. And the best one there for us in this picture is bag A. We've only got the one blue one. And it's an even chance. So we're as likely to get the whites as we are the blues. Well, that's where they're both equal numbers of whites and equal numbers of blues, 3 each in D. Okay, so that's starting off with our words around probability. Certain, likely, even chance. We can add into that unlikely, so we could say it's unlikely to get a blue from bag A because there's only one blue in bag A. Okay, and we can add in other things as well. We can add in the word impossible as well, the opposite of certain. So something's impossible if there's no chance it can happen. So again, I could look at bag E and I could say it's impossible from bag E that I'm going to get a blue sweet because they're all white. Okay, let's move on. So this leads us on to the idea of a probability scale. And we start giving numbers to probabilities to say how likely things are. Something that is completely impossible, cannot happen, we say its probability is 0. Nothing can be less than 0 because nothing can be less likely than impossible. And then at the other end of the scale, we've got 1. Okay, because if we look at something being certain, we'll just say that's a probability of 1. Right at the other end of the scale, nothing can have a probability bigger than 1 because nothing can be more than certain. So there's no way we're going to get that to happen. And then we move into the middle. So we've got an even chance, as likely to happen as not. Well, if that's going to be halfway between 0 and 1, that's going to be the value of half. Or we could write it as a decimal, 0.5. And then we've got other words we can fill in, unlikely and likely and so on. All right, so everything fits in that scale from 0, impossible, all the way up to 1, which is certain, and with an even chance in the middle. We could move this about a little bit. Likely could be anything in this region, and unlikely we might say is anything in this region. So we're not going to give those numbers. But the numbers we work on with probability scales, and we're talking about probabilities really, we should either give fractions or decimals. That's really what we're going to do. And they have to be between 0 and 1. Okay, so that's really important. Sometimes you might see probabilities written as percentages, but really that's not very helpful the further on you get in maths. So we'll try and stick with doing them as fractions or decimals. The fraction or the decimal that's the same as the fraction. Okay, now what we're going to have a look at in a moment is going to see if we can put some real events, some real things that could happen on a probability scale. So in a minute, I'm going to suggest that you pause this video and you get yourself a piece of paper. And on your piece of paper, it could just be a piece of plain A4 paper, something like that, a piece of paper you can draw on. I'll just want you to draw across this probability scale, okay? This scale across the top of the page here. Just draw that on the top of your page. Draw it nice and big enough so that you're going to be able to put things in between, because we're going to put some arrows in here to indicate where things might happen. Okay, where things might be. Is it close to impossible? Is it close to certain? Is it an even chance? And we're going to put some arrows in. So you need to have room to do that drawing. Okay, so I'm going to say now, take a piece of paper. All right, pause the video, draw that bit out, and then come and start the video up again once you're ready to move on to the next bit. Okay, so assuming we're all ready to move on to the next bit, let's have a look at what we're going to do. So we've got our number scale drawn out, our probability scale. So we're going to move on from here, and we're just going to, bear with me 1 second, we're going to look at some events, some things that could happen and where they might fit on our probability scale. So let's have a look at a start. So we're going to draw arrows to roughly show where the following probabilities would be, the following events would be. And we may do this first one together. So let's just have a look and check about this first one. So the first one that appears for us is the probability that you, so each of you individually, your own homes, that you are going to be celebrating your 20th birthday tomorrow. So have a think about that. On the probability scale you've got in front of you, where do you think you should be drawing the arrow to say where this event A should be? Have a quick think. So I'm going to step back onto the probability scale. Now, knowing, as I do, that you're all in year 9, there is no way that any of you are going to be celebrating your 20th birthday tomorrow. And unfortunately, my 20th birthday is a long way in the past as well, so it's the same thing's true for me. I'm not going to be celebrating my 20th birthday tomorrow. So where should we have our arrow drawn? Well, we should have our arrow drawn onto impossible. Okay, so I would hope that we would see, oh dear, I've got a really horrible looking colour here, but I would hope that we would see there and we'd put an A to mark that there. Yours will be a lot neater than mine because I'm struggling with my mouse pointer, but you will have a little arrow pointing there to say A would be at the impossible end of the scale. All right, and now we're going to have a think about where B, C, D, E, and other arrows need to go. All right, so let's move on from that. I think I chose highlight rather than the pointer option that I wanted, which would explain why it looked a bit funny. All right, so let's step on from that. You'll celebrate your 20th birthday tomorrow. We've done that one. All right, the next ones we're just going to go through. You're going to mark them on, and we're going to have a think at the end. We're going to check off at the end where approximately we've got things on. These won't necessarily all be exact. You're going to have a think yourself. Where are they going to be? Are they impossible? Are they certain? Are they even chance of happening? Are they likely or unlikely? So try and position them in the right place. Okay, that's what we're going to try and do. So let me just switch my pointer off. Right, okay. So we move on to the next slide. So you are asked to put an arrow with B on it on your diagram. Draw it as quick as you can. So mark a B on there. So the next baby born in Westport will be a boy. where should event B go on your scale? Okay, and as I say, we'll look at that at the end in a minute. Let's go on to our next one then. C. It will rain in Westport on the 15th of August. Okay, so you're going to have to think about that. It will rain in Westport on the 15th of August. Whereabouts is that going to be? Is it going to be impossible? Is it going to be certain? Is it an even chance? Is it likely? Is it unlikely? Draw an arrow, put C next to it. On to D. Right, similar sort of thing here, but it's now saying it will rain in Sydney on the 17th of November. So it will rain in Sydney on the 17th of November. Have a think about where that will go. Is that going to be a similar sort of place to Westport for C, or is it going to be somewhere a little different on your scale? On to E. You will drink something this week. So you individually, each of you, will have something to drink this week. Where is E going to go on your scale? Draw it on. On to F. So here with F, we've got a spinner with 5 different colours on it: red, orange, purple, yellow, green. When we spin it, we want to know how likely is it this spinner will land on red. Where is that going to go? Is it certain? Is it impossible? Or is it somewhere in between? So mark an arrow on with F. On to G. So we roll 1 die. Okay, so we've got 1 die. If we had more than 1, we'd call them dice, but with just 1, it's a die. And we roll the die. It's an ordinary die, and we want to know how likely is it we get an odd number. Is it certain? Is it impossible? Is it somewhere in between? So mark that on with a G on your scale. On to H. So here we've got a bag. It's got some green counters in it. It's got some red counters in it. How likely is it you would pick a green counter from that bag? Mark that on your probability scale with a H. Right. I. So there's a raffle for a PS4. You'll win the PS4 if you win the raffle. There are 500 tickets that are sold, and you bought 2 of those 500 tickets. So I've got to think, how likely is it that you're going to win that raffle? Draw your arrow with an I on it. All right, now let's look at this the other way. So there was this raffle for the PS4. Yep, you bought 2 tickets. 500 were sold. What's the chance of you not winning? Is that certain? Is it impossible? Is it something else? Have a think about where J should go. What's the likelihood, the chance of you not winning? Okay, so in summary, these are the ones that we've just worked through. We've worked through from A to J, and you should have these marked on your diagram somewhere. Okay, so we can see where they all go. So I'm going to go through now and just put what I might think about some of these ones. You may not agree exactly. I'd be very surprised if we all agree exactly, but hopefully you're getting the right sort of idea as to where things should go, where things should fall. So let's have a look and see how we get on. So our first one, we said, celebrate your 20th birthday tomorrow. Well, we know that's not going to happen. Okay, so I'm just going to change so I can draw with my pen. We know that A should have been around about there. It's just not going to happen. Okay, let's go back. The next baby born in Westport will be a boy. Okay, although it's not exactly 50-50 boys and girls being born. It's very very small amount in favour of females. But it really is, to all intents and purposes, 50-50. So it's an even chance we should have for that. So let's just mark our even chance. Whoops, I got a bit too far there. Let's just mark our even chance on. So if we come back into here, again, I bring my pointer's still the pen. So I should have, whoops, dear me. Let's try that again. I lost my pointer. Let's put my pen back on. That's better. So I should have B being there. It really is 50-50 as good as. Let's go back then. It will rain in Westport on the 15th of August. 15th of August, what time of year is that for us? So 15th of August, we're just sort of coming into late winter, early spring, that kind of thing. So it's probably quite likely it's going to be a bit of rain in there. Probably more likely than not. So let's move him in and have a look at where we're going to put him. It's probably more likely than not. I'm going to put mine about here for C. All right, depends. You could have yours anywhere in the area where it says likely. I think it's probably more likely than unlikely that that's going to happen. Let's go back again. It will rain in Sydney, right? Now, Sydney in Australia, 17th of November. 17th of November, that's getting to sort of a warmer time of year, isn't it? And you'd probably expect with somewhere like Sydney, it's going to be less likely to rain than Westport. So let's bring that back up. Whoops, going the wrong way. Let's bring him back up. Could do with bringing it back up the right way. It's a bit tricky. All right, I think that's somewhere in this area, this unlikely area. So I'm just going to put it down here for the time being and say that's D. All right, so see how you're getting on. A bit less likely it'll rain at that time of year in Sydney. Let's go back. You will drink something this week. Well, you will drink something this week. You will definitely drink something this week, won't you? So that should be out here. Everyone should have that in the right place. There is no one this week who is not going to be drinking something. So there we go. There's our E. Let's go back. When spun, the spinner will land on red. If you remember, the spinner had 5 different colours, and they were all the same sort of shape. So it's less than half chance that it's going to land on red. There's only 1 out of 5 of the areas that it could land on that's red. So if we go back to that, it's probably not dissimilar to this sort of area here. Okay, so I'm going to say that's F, because I've got to think about each one of those colours has an equal chance of happening. So it's probably around about there-ish. You get an odd number when you roll a die. Well, 1, 3, 5 are on an ordinary die. You've got 2, 4, and 6 as well. Half the numbers are odd, so it's a even chance. So we're back with an even chance here, and we should then get that we're in the same spot. So we were on to G, weren't we? It's in the same position as B. Let's go back again. H, you pick a green counter from the bag. Now, the bag, let's just slip to it quickly. We can see there are 5 greens and 2 reds. So we can actually say there is a higher chance. It's more likely that you will get a green counter than a red counter. So let's mark him on. That's more likely. That's going to happen. Again, I think somewhere in here, and we're going to call that H. Again, don't worry. You're not exactly with me. We're just working through this together. If you've got the right sort of idea about likely and unlikely, that's the main thing. You got it on the right side of evens. All right, so that was that. We then have the raffle for the PS4. We bought 2 tickets, but there were 500. So our chance of winning is not actually great. We only got 2 of the tickets. 500 different ones could win. We've got 2 of them. So it is not impossible. We could still win, but it's not incredibly likely. So we're going to be down here somewhere for where we got now to I. And then looking at it the other way, what's the chance we didn't win with our 2 tickets out of 500? Well, that's actually much more likely. This I here then becomes a J right up at the other end, near to certain. Not certain, but it's pretty unlikely because we don't have that many tickets. Okay? So pretty close to certain, rather. Pretty unlikely we'll win, but pretty close to certain we won't win. So we got to scale roughly that kind of thing. So hopefully you got something in those lines. As I said, the main thing is to understand the impossible, even, certain bit, and whether things are likely or unlikely. So whether you've got I, D, or F in the same position as me, doesn't really matter so much as long as they're in the right sort of area. Whether you've got H, C, and J in the right position as me, doesn't really matter as long as they're in the right sort of area. They're saying they're unlikely or they're likely. Okay, good job. But we can be a bit more precise about some of this stuff as well. We can say what some of these probabilities are going to be. We can say what they are. So, chance of me celebrating my 20th birthday tomorrow is 0. 0, remember, means impossible. Are there any other ones of these that are obvious? Well, we will drink something this week. That's certain. So that's a 1. Okay. Anything else we can say on here for sure? The next baby born in Westport, as I said, it's not necessarily 50-50. It's pretty close, but it's close enough for us to say we'd expect that to be around about half as the probability then. It will rain in Westport. We can't really say that exactly. We could possibly look back at weather patterns for previous years and whether it rains or not. And if we got that, we might be able to have an estimate as to what we think the probability would be. If it rained, 2 out of 3 years, we might say it was 2/3. We might want a bigger sample than that and say, well, let's look back over the last 100 years and how many days did it rain on the 15th of August and then use that a bit more. The same for Sydney. We'd have to probably look at the data and see what's coming out from historical weather results. The spinner, remember, there were 5 colours. Only one of them is red. So we have a 1 in 5 chance. Yeah, a 1 in 5 chance of getting that red. The odd number, well, there were half of them again. It was an evens one, wasn't it? So we can say that definitely probability is a half. We pick a green counter from the bag. There were 5 green counters and 7 counters altogether. 5 out of the 7 are green. 5 out of 7. We had 2 tickets out of 500 for the PS4. So 2 chances in 500 of winning. That simplifies down because both of those numbers are even. 2 out of 500 is a good answer. Both of those numbers are even. So we can say it's 1 out of 250. 1 out of 250. And then the other way around. Well, what's the chance we didn't win? Well, 498 times out of 500, we would not have won. So we can look at that then and say, okay, that simplifies 2. They're both even. That will go to 249 and 250. Fairly high then, isn't it? Fairly high. Okay. Good job. Right, now let's have a look at a couple of questions and then you can do some of the stuff in EP. So, let's have a look. There are 30 students in a class, 16 boys, 14 girls. What's the probability that a boy will be chosen if we choose someone from that class at random? We have 16 boys. We have 30 girls, 30 students altogether. 16 out of the 30. There are 30 different students we could choose. 16 of them are boys. So we're just going to start by saying, okay, 16 of them are boys. Out of the 30, we've got 16 out of 30 chance of choosing a boy. Again, they're both even. So we can simplify that fraction down. We know that. I can divide that by 2 to get 8. I can divide that by 2 to get 15. 8 out of 15, and they will not divide any further. My 8 doesn't look great there, does it? Looks a little better. Let's go on to our bag then. We've got 3 green, 6 blue, and 6 red. And one marble is taken out at random. What's the probability we get a red one? So our red ones, let's have a look. Our red ones are here, aren't they? We're saying that we have 6 red ones. But how many marbles were there altogether in the bag? Because we need to 6 out of how many? Well, we've got 6 red, 6 blue, 3 green. 6, 6, and 3. That's going to give me 15. I'm happy with that. 15 marbles in total. I'm really pushing it now to see whether I can write using this. There we are. So 6 out of those 15 were red. So my chance of getting a red is 6 out of 15. 3s go into both of these. 2 doesn't work because that's 15 on the bottom, but 3s go into both. 3s go into 6 twice, and 3s goes into 15 5 times. 2/5. Less than half then. Less than half a chance, but that's less than half the marbles, isn't it? Yeah? The total marbles was 15. We only had 6. And a green marble, well, there are 3 greens. Again, still out of the 15. So it's 3 out of the 15. And again, both of those can be divided by 3. 1 lot on the top, and 3's into 15 goes 5, 1/5. And then just to finish with our question 3, probability of choosing the letter B at random from the word alphabet. There is the B. How many letters are there? There are 1, 2, 3, 4, 5, 6, 7, 8 altogether. So my chance of getting the B is just 1 out of 8. The choosing the letter A at random from the word alphabet, we've got to be a little bit more careful here because there are 2 A's in alphabet. So now we've got 2 chances in 8, 2/8 of getting the A, 1/4. Okay, both of those are even. They cancel down by 2, 1/4. Okay, so there is something up here which I'm going to leave on the screen. You might want to have a think about this. You could pause the video at this point and have a think about what's going to happen here. What will be the probabilities? I will put the answers up to those in a minute so you can have a look, and then there'll be the exercises in EP to get on with. But hopefully that's all helped. This idea of understanding impossible, certain, even chance, and things being likely and unlikely, and how to get probabilities is all really helpful. It helps us to understand stuff, and as I usually say to students, and I'd say in front of you if I was here, good thing about learning probability is it means it's less likely that people can fool you. All right, there are some things that seem like they're really good. They're really going to be a good chance for you to do well, but actually people understand probability and they try and trick people with it at times. So if you understand probability, it's less likely you can be tricked by people. Okay, so you can pause the video here, have a look at that if you want, and then I'm going to go on and just go through the answers to these ones. So if we have a fair 6-sided die, it has got these numbers on it. 1, 2, 3, 4, 5, and 6. Okay. The probability we get 6, well, there's only one of those numbers that's a 6. So it's 1 out of the 6. Probability we get a 7. Can't see a 7 there at all. It's impossible. 0. Cannot happen. Anything that's impossible, probability 0. Probability of getting a 1? Well, again, there's just one of those, isn't there? So it's 1 out of the 6. Probability of getting a prime number. What's a prime number? Exactly, remember, exactly 2 factors. Exactly 2 factors. Which ones of those have exactly 2 factors? So let's have a look. Let's list them out, the ones that do. Well, 1 is no good. It only has 1 factor. 2 is the only even prime. It has that. 2 factors. 3 has exactly 2 factors. 4 doesn't because 2 will go into it as well. 5 does. 6 doesn't because 3 will go into it as well. So I've got 2, 3, 5. I've got 3 of the 6 numbers. 3 out of the 6, or if you're ahead of me already on this, half the numbers. 1 out of 2. We can divide the 3 by 3, divide the 6 by 3. An odd number. We went through this one a little earlier with one of the ones you were looking at on the number scale. So half the numbers are odd. 1 out of 2. 3 out of 6 again, 1 out of 2. An even number, just the same. Half the numbers are even. Okay, 3 out of 6 or 1 out of 2. Either a 1 or a 4. So this time we're allowed to have the 1 or the 4. Well, 2 of those work for us. And that's 2 then out of the 6 that we had together. And I've just lost my pointer for a minute. There he comes. He's come back. 2 out of the 6 is 1 out of 3. Each of those is even, so we can divide them down. Okay, guys, on you go with EP.